As the 1900s began, there was a feeling of hope and excitement, especially in the world of medicine. Scientists were working hard in their labs, driven by a strong desire to understand how the human body works. It was a time of amazing discoveries about bacteria, which led to new ways to control diseases. However, there was still a big problem: bacterial infections. These tiny enemies were a constant danger, making even simple medical procedures risky. Imagine a time when a small cut could become a life-threatening infection, or childbirth, usually a happy event, was feared because of deadly infections. This was the reality in the early 1900s, before we had antibiotics. In the beautiful countryside of Scotland, a young boy named Alexander Fleming was born in 1881. The rolling hills and lush green fields of the Scottish landscape were his playground. He was the seventh of 8 children, and his family lived on a farm in the small village of Lochfield. Life was simple, and young Alexander spent his days exploring the natural world around him, developing a deep appreciation for the beauty and complexity of nature. He grew up surrounded by nature, not knowing that he would one day make a discovery that would change medicine forever. His early years were filled with the sights and sounds of rural life: cows mooing in the fields, the rustle of leaves in the wind, and the distant call of birds. These experiences instilled in him a sense of curiosity and a desire to understand the world around him. Fleming's journey to becoming a top scientist is both unlikely and inspiring. Despite the humble beginnings, his keen mind and relentless curiosity set him on a path that would lead him far from the farm. He attended the local school where his teachers quickly recognized his potential. Encouraged by his family and educators, he pursued further education, eventually earning a scholarship to attend Kilmarnock Academy. He was very smart and curious, and this led him from a small country school to the famous St. Mary's Hospital Medical School in London. At St. Mary's, he excelled in his studies and was particularly drawn to the field of bacteriology. His professors noted his meticulous nature and his ability to think critically about complex problems. It was here that he began to lay the groundwork for his future groundbreaking discoveries.
World War I started just as I was beginning my medical career. The war brought with it unprecedented challenges and horrors. As a young doctor, I was thrust into the heart of the conflict, working on the front lines to treat wounded soldiers. The conditions were harsh, and the medical staff was often overwhelmed by the sheer number of casualties. I saw firsthand the terrible effects of war wounds and how deadly infections could be. Soldiers who survived the initial trauma of their injuries often succumbed to infections that we were powerless to stop. The sight of young men suffering and dying from infections that we couldn't treat was a constant source of frustration and sorrow for me. This experience had a big impact on me and made me want to find better ways to fight these infections that were hurting so many soldiers. It was during this time that I began to think deeply about the nature of bacteria and how we might combat them more effectively. This drive to find a solution to the problem of bacterial infections would eventually lead me to one of the most important discoveries in medical history: penicillin.
In 1928, something amazing happened in Fleming's messy lab. It seemed like an ordinary day, but it would change medical history forever. Fleming, known for his careful observations and a bit of luck, came back from vacation to find something strange. A type of mold had accidentally grown in one of his petri dishes, and it was stopping the bacteria from growing.
I was so curious. What was this mold, and why was it so good at killing the bacteria? I found out it was called Penicillium notatum, and after studying it more, I discovered that it made a substance that could kill many different types of bacteria. I named it penicillin.
Fleming was excited, but he knew it wouldn't be easy to turn his discovery into a medicine. The journey from a petri dish to a life-saving drug was fraught with obstacles. Fleming's initial excitement was tempered by the reality of the scientific and logistical challenges that lay ahead. Back then, it was hard to make a lot of penicillin, and it didn't seem to last very long. The process of extracting and purifying penicillin was incredibly complex and inefficient. The equipment available at the time was rudimentary, and the methods were not yet refined. This made large-scale production nearly impossible. Some people even doubted if it would work at all. The scientific community was divided, with many experts skeptical about the practical applications of penicillin. They questioned its stability, its efficacy, and whether it could be produced in sufficient quantities to make a real difference. Despite these challenges, Fleming shared his findings in 1929, explaining that penicillin could be a powerful antibacterial agent. He presented his research to a room full of peers, hoping to inspire further investigation and collaboration. Fleming's presentation was detailed and passionate, highlighting the potential of penicillin to revolutionize medicine.
Sadly, many doctors didn't believe in my discovery at first. They were entrenched in their ways, relying on traditional treatments and skeptical of new, unproven methods. The medical community was slow to embrace change, and my findings were met with resistance and doubt. They were hesitant to try new things. The fear of the unknown and the comfort of established practices made it difficult for many to see the potential of penicillin. It was a time when innovation was often met with suspicion and the road to acceptance was long and arduous. But I didn't give up. I continued my work, driven by the belief that penicillin could save countless lives. The journey was filled with setbacks and frustrations, but my determination never wavered. I knew that perseverance was key to overcoming the obstacles in my path. I kept experimenting with penicillin because I knew it could help people. Each experiment brought new insights and challenges, but also hope. The potential to combat infections and save lives was a powerful motivator, and it kept me going through the toughest times. But I didn't have the money or the right team to turn penicillin into a real treatment. The lack of funding and resources was a constant hurdle. Despite these limitations, I remained committed to my research, knowing that the true potential of penicillin was yet to be realized. The dream of transforming this mold juice into a life-saving drug was always at the forefront of my mind.
The story of penicillin might have ended there with Alexander Fleming's initial discovery in 1928. He had noticed that a mold called Penicillium notatum could kill a wide range of bacteria, but he couldn't purify it or produce it in large quantities. But luckily, two brilliant scientists, Howard Florey and Ernst Boris Chain, wouldn't let that happen. They saw the potential in Fleming's work and decided to take it further. Howard Florey and Ernst Boris Chain, both from Oxford University, were determined to unlock the secrets of penicillin and make it available for medical use.
In 1939 at Oxford University, we found Fleming's forgotten paper about penicillin. It was like discovering a hidden treasure, a key to a new world of medical possibilities. We were fascinated by the idea that this mold could kill bacteria, and we knew we had to investigate further.
We were so interested in its potential that we decided to try and purify it. The process was challenging, requiring meticulous work and countless experiments. We had to find a way to extract the active substance from the mold and make enough to use as a medicine. This was no small feat, as the yields were initially very low. But we persevered, driven by the hope that penicillin could save countless lives.
Florey, a great leader, and Chain, a brilliant biochemist, put together a team of dedicated researchers. They worked tirelessly, often late into the night, to solve the many problems they faced. Chain's expertise in biochemistry was crucial in understanding the complex nature of penicillin and how to stabilize it. Together, they assembled a team of skilled scientists, each bringing their own unique talents to the project.
Together, we overcame many difficulties, from finding the right growth medium for the mold to developing methods for large-scale production. We faced numerous setbacks, but each failure brought us closer to success. Finally, we found a way to produce enough penicillin to use in treatments.
Our work led to the first tests of penicillin on sick people. These initial trials were promising, showing that penicillin could effectively treat bacterial infections. This was a huge step forward in fighting bacterial infections, marking the beginning of a new era in medicine. The Oxford team's dedication and perseverance turned Fleming's discovery into a life-saving drug that would go on to save millions of lives.
When World War II started in 1939, finding a way to make and use penicillin quickly became even more urgent. The war was causing terrible infections and many soldiers were dying. Penicillin, with its ability to fight these infections, offered hope. The Allied government saw how important penicillin was and gave money to produce it on a large scale. Factories were built, and soon penicillin was being sent to soldiers all over the world. Its impact was incredible. Soldiers who would have died from their wounds were given a chance to live. Amputations, which were once common, became less necessary. While discovering penicillin is Fleming's most famous accomplishment, he also did many other important things in science.
Throughout my career, I made significant progress in understanding antiseptics, which are important for preventing infections in the first place. I also did important research on lysozymes, which are found in our bodily fluids and naturally kill bacteria. My work on lysozymes helped us understand how our bodies fight off infections.
In 1945, Alexander Fleming, Howard Florey, and Ernst Boris Chain were awarded the Nobel Prize in Physiology or Medicine for discovering and developing penicillin. This prestigious award solidified Fleming's place among the greatest scientists in history, but perhaps the most important part of Fleming's legacy is how his accidental discovery continues to impact human health today. Penicillin and the antibiotics that came after it have completely changed medicine, saving countless lives and reducing suffering worldwide.